Hello, welcome. Today we are here to solve a question called merge to sorted lists. Merge to sorted lists. Question number 21 from lead code. So basically, you are given the heads of two sorted linked lists. So there are two linked lists which are already sorted, guys, which are already sorted. So we need to merge two lists, one sorted, into one. So there are two lists. Okay, there are two lists. We need to merge these two into a single list. We need to merge them into a single list. And it should be a sorted one. It should be a sorted one. So this should be made by splicing together the nodes of the first two lists. So what they're saying is we should make this list. We should make a new list. Whatever the single list was there, we should make this new list by combining these two single lists. We should not create any new linked list. We need to combine them and we need to make this single linked list. That is what they are saying here. Okay. Return the head of the merged list. So we need to return the starting point. So obviously, after merging two linked lists, you will get a one of the starting point will be your starting point. You need to return that starting point basically. So I'll take you through this question with one more example, then we'll have a better clarity. So in this example, you have two lists, two linked lists. What are the two linked lists? 1, 2, 3, 1, 2, 4, 1, 3, 4. Now they are merging. This one and this one, obviously they are same. So you can put any one. So they have taken blue color one. Let's say this is a blue color, this is a red color. Okay, blue color one they have taken. Now they'll go to the next value. Now 1 and 3. Obviously 1 is smaller, they have taken red one. Now 2, 3. Obviously 2 is smaller, they have taken 2. 3 and 4, which one is smaller? 3 is smaller, they have taken 3. And next 4 and 4, which one is smaller? 4 is like both are same. Now initially they have taken, when they both are same, initially they have taken blue color. Now they have taken red color. Now they have taken red color, which means they are saying us if the values are same, if the values are same, okay, you can take anyone. You can take any. So you can pick this node or this node. Both. Anything is fine. Anything is fine. Okay. This is what they are trying to say. This is what they are trying to say, guys. Okay. If the values are same, you can pick anyone. Both are fine. Anything. You can pick first list or second list. Okay. This is what the question is. This is what the question is. Now let's see the constraints, what they have given. Okay, these are the constraints, guys. You can see here. The first constraint, number of nodes in the list can be range of 0 to 50. 0 to 50, which means you can get a linked list with 0 nodes. 0 nodes. What does this mean, guys? 0 nodes. What does this mean? Whenever I say 0 nodes, the linked list, let's say list 1 is empty. Empty. How you can say whether list 1 is empty or not? If the list 1 is empty, this will be pointed to null. If list 1 is empty, this will be pointed to null. Okay, guys. And what is another constraint? Node values which in the range of -100 to +100. So the values inside the nodes. Okay, the value part, this value part can be in the range of -100 to +100, +100. What was the next thing? Both list 1 and list 2 are sorted in non-decreasing order. What is non-decreasing order? Non-decreasing order is nothing but they are sorted in ascending order. They are sorted in ascending order, but the elements of linked list can also contain duplicates. The elements can also be duplicates. The elements can also be duplicates. Remember this thing, guys. Whenever they are saying non-decreasing order, whenever they are saying non-decreasing order, the elements of that list will be duplicates. There is a possibility that it contains a duplicate values. It contains a duplicate values. Okay. I hope the question is clear. Now let's start. Let's see how we can actually merge this linked list. Now we will see how we can actually merge this linked list, guys. We'll see that. We will see that one. So let's take two linked lists first. Let's take two linked lists first. Let's take one, which is going to 4, which is going to 5, which is going to 5. And 5 to, obviously, null. 5 to null. Okay, this is your list 1. List 1. Let's take a different name. Let's take A. This is your list A. Now let's take 2, 3, 4, and null. 2, 3, 4, and null. This is your list B. This is your list B, guys. So we have taken two lists. We have taken two lists. List A, list 1. Where list A contains what all elements? List A contains what all elements? 1, 1, 2, sorry, 1, 4, and 5. 1, 4, and 5. 1, 4, 5. And list 2 contains, which is B list contains 2, 3, and 4. 2, 3, and 4. 2, 3, and 4. Now we need to merge them. Now we need to merge them. So before we merge, how we can merge? We need to merge it into a single list. We need to merge it into a single list, which means it has only one starting node. One starting node. It will not have two starting nodes. It will have only one starting node. So as a first step, we need to decide on the starting node. We need to decide on the starting node. If you observe, which can be the starting node, guys, in this potential nodes, two nodes, like first node of list A, first node of list B, which node can be a possible first node of the entire merged list? After merging these two lists, which can be a first node, which can be the starting node? This one, right? Because one is smaller. How we are saying one is less than 2? That's why we are saying one is your starting node. One is your starting node. Yes or no, guys? Are you getting the point? Are you getting this point? Are you getting my point? One is the starting node because one is less than 2. One is less than 2. So first node of list A is your starting node. First node of list A is your starting node. Is this like same thing that will repeat every time? Okay. Do we have starting node always in the first list? Are we sure that always list A will have first node as a starting node for the entire linked list? We can't say, right? Here it is 1. Let's say if this is something like, let's say what we can do. If you think this is 3, which will be the starting node, guys? 2 or 3? Obviously, this node will become starting node. Yes or no? This node will become starting node because first node value is not less than second node value. This condition will become false. This condition will become false, which means second list B is first node is the starting node. First node is the starting node. So we can't be sure every time first list have a smaller value. So we need to check. We need to check which node can become a starting node. Which node can become a starting node. In this example, this is our starting node. Which is our starting node? Which is our starting node? Which is our starting node, guys? Which is our starting node? This is our starting node. So 1 is less than 2. So 1 became our starting node. So now let's point this to a Sn. Sn. Once this became your starting node, do we still need to point here? Do we still need to point here? A. A is pointing to where? First node. Do I still need to point there? No. I need to point my A to next value. I need to move my A to next value. Why I need to move my A to next value? Because I already completed with the first node of the list A. First node of the list A is already completed. That's why I will move to the next node. Why I am moving only A? Why I am not moving B to next node? Because this is not yet completed. This is not yet completed. Okay, guys, are you getting my point? So that is the reason after deciding the first node, if the first node exists in the first list, move first list pointer to next. Move first list pointer to next. And what we need to, okay, I hope this is clear till now, right? Okay. And at the end, what I need to return as the answer, guys? What I need to return as the answer? My first node's address. After deciding your first node, store this in the answer variable. Store this in the answer variable. So whenever you decide on the first node or starting node for that sense, whenever we decide on the starting node, store its address into the answer variable. Okay guys, I hope this is clear. Why I'm storing? Because I need to return the answer. Which answer I need to return? My first node address. That's why we are storing it, guys. Okay. So now this is your first node. We have fixed, but we need to link them, right? So what should be the next node, guys? What will be the potential next node? Obviously 2. We are seeing this. We know obviously 2 will be the second node. But how you can say? So we need to compare. What we need to compare? A dot value. A dot value should be compared with B dot value. A dot value should be compared with B dot value. If this condition is true, which node is smaller one? A node is smaller one. If this condition is false, B node is the smaller one. If this condition is true, A node is the smaller one. If this condition is false, B node is the smaller one. B node is the smaller one. Now, what is this node value? A node value is 4. B node value is 2, which is smaller one? Obviously, 2 is the smaller one. So this condition became false. Whenever this is false, B node is the smaller one. So I need to link Sn dot next to B. Sn dot next to B. After that, I will move my B value. I will move B to the next node. Why I am moving B to the next node? Because this is done. 2 is done. So simply move to the next node. Simply B will be moved to the next node. Again, I'll compare which two, guys? I'll compare A node value with B node value. A node value with B node value. A node value is 4. B node value is 3. And this condition is false again. This condition is false again. Then what I need to do? I need to link this particular 2 to 3. 2 to 3. But you guys say me, do I have any pointer pointing to 2? Do I have any pointer pointing to 2 here? No, right? How I can link 2 to 3 then? How I can link 2 to 3 then? So to link from 2 to 3, whenever you are linking from 1 to 2, move your Sn from first place to second place. Move your Sn from first place to second place. Why I am moving from Sn pointer? We are moving Sn pointer because this, whatever the nodes that come next, those should be linked to node 2. Those should be linked to node 2. That was the reason we are moving Sn to the next node. We are moving Sn to the next node. We are moving Sn to the next node, guys. We are moving Sn to the next node. Now Sn dot next will become your 3. We are become 3. I hope this is clear, guys. Initially, Sn is pointing to node 1. Now we are moving it to node 2. Why we are moving it to node 2? Because I need to link node 2 to node 3. I need to link node 2 to node 3. But I don't have anything pointing to 2. That's why we are moving Sn every time. After linking node 2 to node 3, again Sn will go to next node. Again Sn will go to next node. Why it is going to next node again? Because whatever the remaining nodes are there, that will be linked to 3 only. That will be linked to 3 only. That is the reason, guys. That is the reason. Okay. Again, B will be moving to the next node. B will be moving to the next node. Now again, 4 and 4. 4 less than 4. Is this condition true, guys? Is this condition true? Obviously, this condition is false. Whenever this is false, what we will do? We'll go to the B node. So according to our logic, whenever the values are same, we are going to the second list node only, which means Sn dot next will be linked to B. Sn is moved to next pointer. B is moved to next. B moved to next, which means B became null. Oh, B became null, guys. Sn moved to 4, B became null. Now B became what? What is the value of B? B's value is null. Now, can I compare B with A? Can I compare B with A? Okay. Before this one, do I have any values left in list 1? Obviously, yes, 4 and 5 are yet pending, right? These are yet pending values. These values are yet pending. But do I have any values in list B? Do I have any values in list B? No, nothing. B is completed. B is completed, but A is pending. A is pending. So in this case, what I need to do is wherever Sn is there, I will link Sn to A. Sn to A. I will be linking from Sn to A, guys. Sn to A. Why I'm linking? Obviously, nothing is there in the second list. Only first list values are pending. So that's why we are simply linking. You can ask me, sir, by linking, will that be enough? Yes. The remaining parts are already linked, right? The remaining parts are already linked. I just need to link from 4 to 4. That's all. If B is completed, A is not completed, which means A is not empty. Not empty in the sense A is not equal to null. That's why we are linking A. If B is not null, we will link B because every time it is not sure that every time A will not be empty. Sometimes B might be having some values. So if A is not empty, link A. If B is not empty, we need to link B. We can only compare two values if both are pointing to a valid nodes. Both are pointing to a valid nodes, guys. I hope this is clear. Okay, so we are deciding the first node. We are deciding the starting node and marking it as the answer. We are marking it as the answer. After marking it as the answer, after marking this as the answer, what we are doing? What we are doing? We are pointing A to next node, B to the first node. Why we are pointing B to first node only? Because we are pointing to B to first node only because B is not the starting node. That's all. Again, I'll compare A node's value with B node's value. Smaller one is 2. I will link 1 to 2. I will link 1 to 2. I will be linking 1 to 1 to 2, guys. I will be linking 1 to 1 to 2. Okay. After linking 1 to 2, what we will do? Again, after 2 is linked, I'll move my B to next value. In this way, the process goes. In this way, the process goes, guys. I hope this is clear to everyone. Okay, let me clear this drawing. Let me clear this drawing. Let me go back to the code. Let me code this for you people. Let me code this for you people. So first thing, guys, what is the first thing? We have 2 pointers. One is answer. The other one is starting node. Okay. Now I need to decide the starting node. Decide starting node. How to decide the starting node? If list1 dot value less than list2 dot value, which means list1 is the starting node. Okay, list1 is the starting node, which means Sn equal to list1. As list1 first node is completed, we will simply move list1 equal to list1 dot next. List1 equal to list1 dot next. Why we are moving list1? Already first node is the starting node. That's why we are moving list1 to the next pointer. Else Sn equal to list2 equal to list2 dot next. List2 dot next. We are moving list2 to next node. Why we are moving list2? Because list2 is the starting node. We are simply moving it to the next node. That's all, guys. Very simple thing. Okay. After that, I need to run a loop. Let's come to condition. What I need to do every time? What I need to every time? Every time I need to check for the value. If list1 dot value less than list2 dot value, as I know, if the value is less than list2 dot value, obviously my Sn dot next will be list1. Sn dot next will be list1. Once list1 is completed, what I need to do? List1 equal to list1 dot next. We are simply, after the value is compared, after the value is attached, we are going to the next value. That's all, nothing much, guys. After, so what I'm doing is 1, 2, 3. Okay, here we have 0, 1, 2. Okay, this is my starting node. This is my starting node. As you guys know, above condition will decide my starting node. Now this is my uh, list one. List one. Let's say this is 10. This is 11. This is 12. This is my list 2. Now if you observe, value is 2, value is 10. So whenever 2 is less than 10, I know 2 will be the obviously next node. So I will link it. I will move my list 1 to next pointer. Okay. 2 we will link 2, we'll go to next one, which means 2 is done now. That's why we are going to 3. That's all, guys. That's what I'm saying here. Okay. If not 2, if not 2, sn dot next will become which one? List 2. List 2 equal to list 2 dot next, list 2 dot next, and sn will be moved. Why we are moving sn? Because every time we need to go to next node. After linking the next node, I need to jump to next node, because once I link the next node, whatever the next upcoming nodes are coming, those will be linked to next node. Okay, next node, we are moving to next node because whatever the upcoming nodes are coming, those should be linked to next node, right? Not to the current node every time. That's why, guys, we are doing. And how many times I need to repeat this process? Why? List 1 not equal to null and list 2 not equal to null. Why both should not be equal to null? If one is null, how can I compare? How can I compare? That's all. That's what the reason is. And after completing, if list 1 is still null, if list 1 is not null, let the list 1 have values, then what we need to do? Then what we need to do, guys? We need to simply sn dot next equal to list 1. That's all. Same for list 2. If list 2 is not completed, let's say list 2 is not completed, not null, then what I need to do? Sn dot next equal to list 2. At the end, as we already stored the answer, oh, we missed storing the answer. We missed storing the answer. Where I need to store the answer? After deciding Sn. After deciding answer equal to Sn. Answer equal to Sn. I hope this is clear, guys. I hope this is clear. And one more step that we forgot is list. Okay, list length can be how much? List can be 0 also. What if the list 1 is empty? What if list 1 is empty? Let's say list 1 is equal to null. List 1 equal to null, and list 2 equal to 10, 20, 30, guys. What will be the answer in this case, guys? Obviously 10, 20, 30 will be answer, which means list 2 is your answer. So, okay. So if list 1 is null, okay, obviously what will be the answer? Return list 2. Return list 2. Or else if list 2 is null, if list 2 is null, what will be the answer? Return list 1. Return list 1. So let's simply reverse this. Let's understand. Let's say now list 2 is null. What will be the answer? List 1. That's what I have written. These are your base conditions, you can also call. Why we are writing this? Because in the question they clearly mentioned that it can get 0 values also. That's the only reason. If they are not mentioning that, we will not even do this one. Okay. I hope this is clear to everyone. Okay. Let's run this. Okay, we are doing, oh, 1 second, guys. Oh, this is list 1. It's just a typo. That's all, guys. This is completed. I hope you understood the process, guys. Okay. Let me give you a brief again here on this one. So first thing, we are deciding on the first node, starting node. What is the starting node? We are deciding. After deciding the starting node, let's say list 1, which means first node, first value is the starting node. I am going to second node. That's all. If first node is starting, then I am ignoring that. Why I should again compare that? That is my starting, right? Obviously that is decided. I am deciding here only. That's why I'm simply moving to the next node. If it is second, I'm moving my second node. Okay. After that, I'm storing the starting node. Why I'm storing the starting node? Because that is my answer. Right. Obviously, I need to return the merged linked list. Here you can see return the head of merged linked list. That's why we are storing the answer. And I'm writing a condition. Why I wrote the condition? Because I'm comparing both list values, both node values. If the other node is not valid, how can I compare? That's why till both are there, I'll compare, I will merge them. Okay, if list one is lesser than, I will merge it, I'll combine it, and I'll move go to the next node. If list two is smaller one, I'll add it. I will basically link it, and I'll go to the list two next node. And every time I'm moving this one. Why I'm moving SN? Because every time I need to link upcoming nodes with the next pointer. Obviously, I have linked it. I need to go to the next one. Why I need to go to the next one? Because the newly coming nodes will go link to the next one only, right? That's the reason. And these conditions, let's say list one is still having values which are not linked, then we need to link them. You can ask me, sir, why we are not using while loop? Because list one is already sorted. We are just need to link it. That's all. Same for list two also, guys. And then return the answer. Okay. I hope this is clear. If you are going fast, try to listen it in slow. That's all, guys. Thank you so much.